Pow. Oof. Okay. So, like a couple of things. One of the things I talked about earlier on in R230 as one of these computational ideas, right, is the idea that on the computer copies are free, right? Like you make a thing, you can do, on the PC, it's, like Control C and then Control V, right? Copy paste. And that's just because it's just memory like in the computer. So like you can make something that's like extremely complicated and then just make more copies of it. You can use repetition as like a design element. If you have repetition, you can get things like pattern, right, where you repeat things like a certain way with some kind of transformation or some kind of change, which also gets you like rhythm, right? So you might have something that's like A B A B, and then you A B B A B B A, or A B B C B B A. Like all the different kinds of things that you can kind of find in art and in music. You find in architecture. And so like a lot of, and in modern days, like if we look at this example here, you guys know Andy Warhol, your good buddy Andy. Andy Warhol, was one of the like really successful modern artists. And one of the conceits of his art was the idea of art being something that's for mass consumption, that's for mass reproduction. Just like in this case, this is kind of meta, I think, to me, like the idea, like the Campbell soup, can, where like all of the cans of soup, right, have the same kind of graphic, like the same kind of style. But if you look closely, each one is a different like flavor of soup. And then Andy Warhol arranges them in a grid, right? And it's a 7x4 grid. So there's a center line, and then there's 3 on the sides, and then 2 rows, right, in this like composition. So there's also like there are 2 axes, right? But there's also like asymmetry. It's not just a pure grid. There's all kinds of things that work really well with it. Like the thing about Andy Warhol that it took me a long time to understand was like I kind of thought he was a hack. Like I was like, there's a guy who just decided that making copies was like a way. And he said, like, I think he is kind of being ironic and being silly. It's a way to make money too. He's like, I can make a thing and then I can make like a lot of them like really, really quickly, and I can sell each one of those things for like money. So instead of making like one thing, I make 100 things, and I can make 100 monies, and but I think he was onto a lot of things, and I think there's a reason why we still talk about this work. All of this is to say, what Warhol was doing was like a screen printing, process, right, where you'd get he would make a silk screen, and he would have his assistants, go through and make these like prints, right, and so the like printer was the way of manufacturing these things, right, but in the computer it's like trivial. It's so easy to make things and make a lot of things and make like the same things, right? As I'm going to talk about today, it's also trivial to make things and make like slight modifications to them. And that's how we can get really interesting stuff in architecture. And this is where parametric design like comes into play. Because, we looked at last week, like you can take something like a column or like a, any kind of shape. And of course we saw you can play with it. Like you can make it, big and small, right? But if you change those things, instead of doing it yourself with the like slider, if you allow the computer to do that, you can get things that become really interesting very quickly. And so we're going to do, this is like the reason why I'm doing it this way, and the reason why this is going to be kind of a limited like assignment, is because I want you, there's not many things that you need to learn to do this, but I want you to have time to play with it. Okay. So follow along. I'm going to go through some stuff here, and then we're going to do a little bit of Grasshopper. So okay. So Andy Warhol. Okay. If you're not familiar with Andy Warhol, like, good for you. Get familiar. He's a very interesting individual. Architecture. Remember that? Okay. Can anybody tell me in the class what the building on the left is? And some of you might live there or might have lived there. Anybody tell me? Scholars of architecture? What's that building on the left with the 2 towers? You can chat me. You can go loud, which I love to hear from you. I love hearing from you guys. Anybody?
Is it a parking garage?
It has a parking garage. It does, right?
Isn't it in downtown Chicago?
It is in Chicago. It is. It's on the Loop. Yes, just on the Loop. The river is right next to it. It's near the new Apple store, I think, too. Pretty. Nah, maybe not.
Yeah,
Bryce, you know what it's called? What's that?
Isn't it a hotel? I'm pretty sure someone put it in the chat what it's called.
It's apartments. It is. Kyle is right. It is the Marina Towers. Yes.
By Jeannie Gang.
No, that's the Wave build. That but thank you, Jeannie Gang is awesome. No, these are old. These were done in like the late 60s, like 70s. Like so. But anyway, these are but that's good. They have kind of an affinity for that tower. Sorry, not the Wave Tower, the Aqua Tower by Jeannie Gang. That's a good one too. We should look at that price. Okay, thank you. Yes, these are like the Marina City Towers and repetition, right? You have multiple repetitions, right? You have these like pedals. Like each one of these things is an apartment unit. It's not a hotel. They probably have Airbnb in there, although you could probably go there now, even with the pandemic. And each one of these pedals is an apartment, and then they go in towards the hub, and all the circulation is through that like center hub. So they're repeated around an axis, and then they're like repeated, like vertically. So we get this like tower, right? And like skyscrapers are full of repetition, obviously, right? Both horizontally and vertically. But then also, as I think as Yasmin pointed out, there's parking. Like there is a break in these, and then there's like parking in these things that just goes around and around and around, which is not it's sort of like repetitive, but it's a spiral. And there's a fun video you can find online of a car going backed up too far and snapped the cables and went down into the river outside of the building. I don't think anybody died. I don't know. We'll see. Anyway, okay. Second building. What's the one on the right? Does anybody know that building? Oh, yeah, bam. Gabriel's like right on it. Air Force Academy Chapel. Yes, it is a folded plate structure. There is repetition, obviously, totes obs, right, of these things, right, like a big loaf of Air Force, bread, right? But there's also these modules, right, which are copied and mirrored, which is another form of copying. It's copies everywhere, right? So that's actually something interesting. I hadn't quite thought to bring that up today, but modularity. So that's another principle as well. You make a module and use it over and over again, right? Like a Lego kind of. Legos are great. Okay, neat. Excellent. You can also, like I've kind of mentioned, like I copy things in multiple dimensions. Like these, the vertical, horizontal. Anybody know this project? It's not architecture, but you are citizens of the world and well-cultured. So do you know what it is?
The lightning field.
Lightning field. Weston is on. Yeah, do you know? So do you know about it, Weston? You enlighten us? Enlightening us?
Not that much. I just know
Okay.
It's like in New Mexico or something.
Yeah, New Mexico. That's good. And it attracts lightning. Like it's a bunch of metal poles. Yes. My jokes are not dad jokes. I am a dad and I tell jokes, but they're not dad jokes. I want to make that distinction very clear. Yes, so it's a grid of poles in the desert. And this is like land art. This is what is classified as land art, which is art that is like on a massive scale. And I like to think of it as architectural because it's so spatial, right? It is this field. And so like the like gesture of creating a grid like on this like site, right, creates a response in the landscape like to these elements, right? And the fact that they're the same element and they're spaced like the same distance or whatever is key to the art, right? It is creating a field condition. And the lightning, literally activates it, like not just light and sound and like thunder and all that stuff, but the fact that like you have a grid that's like uniform and on one hand it's neat, but on the other hand it's like also kind of like boring, right? Because it's like the same thing. But remember, like, what's the most important thing in architectural communication? Contrast, right? And so, like, when you change like one element by throwing lightning at it, you know, you really create contrast. Moving on. Pantheon, right? El Roma. Someday you will go there. You will go there for study abroad, potentially. But repetition. We would call this polar repetition, right? Because it's arrayed concentrically along a pole. Not a Polish person, but like an axis. Ben's getting my jokes. Thank you, Ben. Thanks for being on camera. Yeah, okay. Oscar gave me a lull there too. Yes. The other thing that I didn't quite get until I got there was, if you look at, you see where my mouse is, if you look at the floor, there is like a checker grid. So there's like repetition, but we skip. So there's like a rhythm to it. And of course, there's repetition and rhythm across here, repetition and rhythm, right? Axes, mirrors, etc., etc., etc. The Romans knew what they were doing, right? They created this field. I'm not going to ask you what this building is because they wrote it on the side of the building. It is the Guggenheim Museum in New York City. Somebody tell me who the architect was. Oh, he's spinning in his grave and he's wearing a cape. Who designed it? Oh, right. Okay. Frank Lloyd Wright. Boom, boom, boom. Yes, FLW. FTW. For the win. I don't know. Okay, cool. Fellow kids. Yes, Frank Lloyd Wright. Repetition, right? The kind of saucer, the kind of you know, teacup, right? That's kind of like articulating outwards. Much better on the inside, right? Once again, it is a spiral, but I do like to think of it as repetition. So we also have repetition in the oculus, and you can see it kind of concentrically sliding up. I think I'm making my point, right? We have not exhausted the potential for repetition in architecture, but when we apply computation, we can get some really interesting stuff. Last one. Speaking of land art, speaking of being in the dead of winter, speaking of not visiting New York City for the last like year and a half, what is this project? Does anybody know what this is? Anybody visit it? Y'all might have been youngins back then, but I would remember it even if I was like 9 or 10. Anybody? Crickets. Architectural crickets. GAs. Show me your knowledge. Ben? No? Ellie? Do you know this one?
Is this also the French guy that did the red stuff around?
This is sorry. Yes, I mean, yes, it is the French guy. It is Christo, and this is the gates. And Christo, which Ben pointed out, is a French guy, and he does these projects where he like wraps things in fabric or does these really large like gestures and things. Famously wrapped the Reichstag in Germany. Had the like parasols in France, and one of the parasols blew. Maybe was it California or France? Maybe it's California. I don't know. Anyway, one of the parasols blew over and killed somebody. Architecture is violence. Anyway, this is the gates, and the gates is Central Park in New York City, and they're orange and they're fabric, and they are these archways, and they're obviously like repetitive, but they activate. Once again, I use that word activate, like that they like bring about this visual interest. This as you on the site, you can see them, you know, from the buildings and things. You can see them from the pathways, right? The bright orange contrasting against the gray New York landscape in the dead of winter. They luckily got some good snow that year. I think it was 2005. I want to say. I think it was maybe 15. Christo's dead, by the way, so he's not making any more of these. But in any case, but they also blow in the wind, And when you're on the path, they create this very cool tunnel effect. It's very cool. Land art. Okay, so repetition, right? If you have like a simple idea well executed, right, it can be really, really dramatic. And a simple idea is actually not that simple, like in execution. Like this took decades to do. Yeah, that's what I'm saying. You walk under the fabric squares. These are about 12, 15 feet high or whatever, and the fabric, stops over your head, and you walk through them like a big tunnel. They're very, it's very, I mean, you can Google it. It's very magical. Closer to home, somebody enlighten me as to the identity of this architecture. I will drop you off at the Nebraska border if you do not know what this project is. Citizens of Iowa, visitors of Iowa. What is this? Yes, thank you, Hunter. High Trestle Trail. It is a ways away from here, but it is not that far away. And this is obviously a form of repetition, right? You have these like metallic kind of archways once again, but they tumble. They actually, as they move, they also they spin. And when you're riding your bike, through them at high speed, it's very neat. You get this cool effect, and they light up at night, which is also neat. I encourage you to visit it. It's pretty cool. Ride your bike. You can pretend you're going through a wormhole. If you get there at night, just make sure you don't run into anybody or anything. Okay, be safe. Yeah, High Trestle Trail. Excellent. Okay, so there's stuff. Last, does anybody know this project? Once again, I would extend this to the GAs because this is a little bit dated at this point. But does anybody know? Not the Lego one, just to the right. What does it look like? Does anybody know? This architect has a very familiar style. Chicago Spire. Kyle, you're on it. Kyle, you know the architect? For bonus points, it is the Chicago Spire. Kyle's right. I mean, you guys could Google it and then impress me. There you go. Santiago Calatrava. Calatrava it has a white paint factory, and he gets paid he gets kickbacks from all the white things that he makes. No, I don't know, not really, but everything he makes is white. And it's just his style. And so this was a project that was meant to be done in Chicago. It would have been one of the tallest buildings in the world, and they dug the hole for it. And then the financial crash happened in 2008, 2009, and they didn't. And so there was just this literally a big hole in downtown Chicago. Anyway, and then at the Legos at the building museum at the Chicago Institute of Architecture, the CIA in Chicago, they had this model of the of the building made out of Legos, and that's about as close as you're going to get to Chicago Spire in this day and age. Transformation. So you've got the repetition, right? You've also got the twisting, right? You've got the like we said, right? You got the High Trestle Trail now, it's vertical. And then scale, right? The radius of the things is actually collapsing as it goes up. It becomes conical. It becomes spire-like. So three things, right? Well, so two things. One, repetition. We're going to talk about that. Two, the other topic of the day is transformation. And because they're all scholars of Rhino and scholars of 3D modeling at this point, you know that the three main transformations are movement, move, rotation, and scale. Okay, movement, rotation, scale. Move, rotate, scale. Okay, and you can do a lot with that. And you put that together with repetition, and you have superpowers. Okay. Let me check my timer. All right, I'm moving on. I might have to do a video because I'm enjoying myself too much. Movement. So just a simple act of making something and moving it, will actually get you pattern, right? And laying out patterns next to each other creates interference, so you get some really interesting kind of graphic effects with these kinds of things. You can also do this with architecture, right? With columns, with articulating a facade. So just the idea of making a copy strategically is extremely powerful. And these are just copied in the x-axis, right? This is what's called op art, and it's a piece by Bridget Riley. And how does it work? Like there's a curve, just one curve, right? But then if you like copy it and you play with the spacing of it, you get these like weird interferences in your brain, right? You look at it and it seems to move, right? So like, you know, when you're there's a that's what like op art is. It's like operational, you know, it's like optical art. It's using the way that your brain like processes images, right, to create like effects. And this is a great piece. But it's a simple idea, right? You can take something and simply make it, you know, obviously drawing a line is pretty easy, but you know, drawing a little bit more complex line, you know, gets you different kinds of effects, right? But you have to like have the right spacing and the right thickness and the right kind of line to get it to do like that kind of thing. Also, like she crops it, so after it's done, it's been processed, right? That's another idea that I want to put out there. Just like Ben had a really great example last time when he was talking about like, you know, do I write a program to do this like roof that I had? And I said, well, maybe if you do it more than 3 times, it makes sense to like write a program. The thing I want to avail you of is the fact that like, you don't just take what comes out of like these things. So like, for example, you could easily do this, and I will in a second here. But you still like, part of the effect of this is the fact that it's cropped. But Grasshopper, like, yes, you can do trims and stuff like that, but you don't necessarily want to. So what you might do is make this thing and then like crop it, you know, trim it in like Rhino. So you make all these things in like your factory, and then you do the finishing. Like you like stitch the little you know, like alligator on the shirt when it's done. That's your like signature or whatever, right? There's like a little bit of processing that happens that applies more authorship. There's some intentionality, you know, behind that. So like there's the step of like playing with stuff and modifying it and like making a thing, but there's also the kind of finishing like step that is not automatic. Okay. The other thing you can do with things is like, you know, applying color or applying weight. You know, you can export these things and then you can modify them in Illustrator, right? Easily. You can put them into Photoshop, you know, things like that. And that's a way to get different effects in here that you might not know how to do yet in Grasshopper, and they're much easier in other tools, right? So this is why I talk about workflows between different pieces of software. We'll talk about that. Anybody know the author of this work of art? And I'll give you another hint. It actually exists in multiple places and it's different every time. This is Sol LeWitt. And Sol LeWitt was a serial artist, not a serial killer, but similar in the way that a serial killer kills multiple people. A serial artist, the idea is that like it is not just one work, but it is a repetition of that work. And what Sol LeWitt did was that the artwork are the instructions for the art. So you buy these like instructions, and then you like hire like draftspeople or like whatever to actually like make the work. And the work is different every single time because of the way that people like make it and because of where it's made, like what kind of wall it's on, like the shape of it usually influences the final result. Okay. And so this is one of Sol LeWitt's works of serial art. And of course, you can see this is interesting because it takes on this idea of repetition, but the human actor introduces their own like their own authorship, and the space also does too. It changes it. So what's cool about Sol LeWitt is he's like you could consider him like a precursor to computational design or computational art, because the instructions are the interesting thing, right? And then the people are kind of like the computer or the machine that like executes the work. And it's that separation of things, I think, that's something that's really, really critical to understand. Okay. And so Sol LeWitt, I could go on for years about Sol LeWitt, but this is worth noting. Another work of Sol LeWitt's is basically there's a series of these radii. And again, it kind of has a pop artifact. You can see like the interference of these two things, right? But it's actually a pretty simple idea, right? It's the repetition of the circle and the crop that creates this really interesting effect. right, let's do some Grasshopper. Okay, so movement. I'm going to share my Rhino here. Let's see what it looks like. Yep, kabam. Okay, so anyway, I got the video. Don't worry too much about, you know, following every single thing. But if you can, or if you want to, go ahead. I'm going to go ahead and go to the top view. Whatever. Okay, so just to start off with some things, I'm just going to go ahead and make a line. And you can find lines under the curve tab. And the simplest way to make a line so you can make a line between 2 points, but I want to make it even simpler. So I'm going to use there's a certain kind of line. It's called an SDL. And it's going to do that SDL, line SDL. And SDL has a start point, direction, and length. Boom. And start point, you have to actually set a point. And so just to do that, I'm going to do construct point. Construct point. Yeah, point. So it is a little XYZ. To save time, just gonna type these in. So that if you just construct a point and you don't have any coordinates for it, these XYZs would be where you plug in the number slider. You just get a point at 0, 0, 0. Okay, just by default. And I don't really care at this point, so I'm just gonna make it at 0. Okay, so I got my start point. Okay, and then the second thing is a direction. And the direction by default is Z, is like up. Right, you can see it like a teeny tiny thing. I'm gonna go ahead and actually oops, make a little number slider. It's gonna say 50. So the length, right, is the unit. So now it's a line that's like 50 units long, and by default it's up. That's the D. That's the direction. But so this is me in perspective. You can see down here these like XYZ. If you take 2 of these directions, that's a plane. And the default plane is XY. That's flat. That's like the ground or the sky. But the other planes, like the front view would be ZX and the side view would be YZ. And you can make those in Grasshopper. We'll talk about that. But basically, if you're looking for like a direction, so right now in the XY plane, Z is up. If I'm looking down at the XY planes, if I'm in the top view, because I'm drawing this in plan, I'm drawing like a piece of paper, right? What direction, if I want to make a line that goes this way, that goes up, do I do X, Y, or Z? In this drawing, it's not Z because I just showed you. So you've got a 50% chance. Anybody know? Do I do Y or do I do Z?
Y.
Yeah, it's Y. Thank you. Perfect. So Y, and in fact, you just do Y is called a unit Y. And that's just a line. That just tells you I want something in the line. Boom. Now I've got it. Can you see it? It's like red. Okay. And you can see it gets smaller and it gets bigger. Okay. Anyway. So we've made a line. Congratulations. And it's parametric. Now we're gonna move it. So I'm gonna take move. Yeah, you don't even have to like spell it right. That's how smart this is. Just say move. Okay. And you plug in, and then move takes the geometry. So G, any kind of geometry, plug it in. And T is a transform. And remember how this has like a direction? Same thing. This is the direction. Okay. So if I want to move it in the X, type X, and I want the unit X. And I plug it in. And now, you know, everything has like a default. So in the same way that this is 0, 0 by default, when you put in any of these vectors, they move 1 unit. And so I just moved that line, started here, and I moved it 1 unit. Yay! Okay. I'm gonna go ahead and copy paste this, plug it in here. And so now you can see, like, if I play with this, I'm moving it. I'm moving that line. Okay. Fancy. Can you guys see that? Okay. Yeah. So that's it. So that I made a line, I made it move. And that, if you're like Paul Clay, then that's your entire career, right? I took a line for a walk. Okay. And so, like, okay, that's fascinating and extraordinary, right? So that's the move transform takes a geometry, and it takes some kind of some kind of a transform, and the transform is saying like, which direction do you want me to go? Okay, I'll ask you a question.
So the move tab has geometry and motion on the left. Is motion going to be the same thing as transform?
No, let's just focus on this right now. Yeah, it's actually different. Yeah, these are the main the main things. Motion is a different thing in this case.
All right. No, because I mean the component move has, because yours has G and T, ours is G and M, or at least unless I'm doing this.
Are you using this the same one I am?
Yeah, the move component, right?
Are you using Rhino 7?
Oh, maybe not. No,
Are you using Rhino for Mac?
no, Rhino 6 on the Windows computer.
And
I
yours
just
looks-
typed in move and I got GT.
Yeah, I think Oscar, you might have used a different component. Does it look like this with the point and the arrow?
Yeah.
Well, anyway, it shouldn't. I don't know. Maybe I don't know what difference. I don't know.
Yeah. It's
I mean, if you type in move, and it looks like this, you put it in, it should be GT. I don't know. Okay. I would try to find I would make sure that you're using the one that we are, because it might not work the same. I don't know. Otherwise, try plugging it in this for M and see if it works the same way. I'm not sure. Okay. So we have move. And okay, so there's another lesson I want to make here. So right now I made a line. Well, let's say that like I don't like that line. I like that pop art though. I can make a curve. And really I can make anything. Okay, so I just made this in Rhino. Okay, just made like a little curve. Okay. And remember I had these containers. I can put data into the containers and I can do stuff to it. You just have to know what container the right thing is. So there's always a parameters or whatever. This one, I'm just going to use a curve container. And these little black things, they're like hexagons. Okay. And it comes in as a curve. And in order to get that in there, I go to curve, I right click it and I say set curve. And I click on it. And now that curve is in and I can hide this now. Now that curve is in Grasshopper. And instead of the point that I had, I can plug it in instead of the line that I had, whatever, I can plug that in. I'll move it over here for move, and instead of the line, and now I can move that geometry. Oh, okay. Yeah, thanks a lot, Hunter. Yeah, I think if you that's the in the chat, you guys can see that. If you have hang on one second, my stupid screen is doing something. If you go to the display icons, let's see full names. Yeah, I guess it says motion, but it's transform. I don't know. I used to make fun of David Rutan quite a bit, the guy who wrote Grasshopper, because he's like from Hungary and stuff, and he just thinks about things differently than I think is logical sometimes. And so there will be discrepancies like that probably happen. Thanks, Hunter. Appreciate it. Okay, anyway, so you can take an object and move it. Okay. Well, let's go ahead and give ourselves backline. So that's like, not super, and I'm going to hide this for now too. Or turn preview off. So that's like not super exciting. I'm gonna jump ahead a little bit here. Okay, so everything in Grasshopper, right, is basically we talked about how numbers can be used as input. We had the number slider, right? And we talked about how to get numbers in through different components, like the math component or the expression component, panels, number component, all stuff like that. But that's one number. Okay, and I want to get a lot of things. Okay, and so there's I'm going to show you a couple different techniques right now. So the one I like a lot is called a series. And a series component generates, if you look at it, we'll put a panel in here because we'd like to see things. Kaboom. Panel component, the panels, so this is a series. Series is a starting number, which defaults to 0, a number step, which is how much to add to it, and then a count, which is how many times to do it. So it's a little algorithm, right? It's like take 0 and add 1 10 times. And you get a list of numbers from 0 to 9. That's it. Okay. But what we can do with that though is we can take our number sliders, and I'm just going to make a really simple one, just a 10 number slider. And now I can change. So now the starting value is 10, right? I can make the starting value, 1, because I like to start at 1 because I'm not a computer. Okay. And I can make the step different, right? So now, let's do that. You can plug the same one in for different things, but okay. So now I can say, how many numbers do I get? I can have 2 numbers. I can have 10 numbers. I can have it be, I can skip by 3s, by 2s, by 10s. So you got a lot of power right there. Okay. Now, remember the move command that we had, right? We had this number slider and we moved it in. Well, that is just taking the number 57 and saying like, I want to make a vector that's like, 5700. But if I take a list of 10 numbers and I plug it in instead of the number slider, I got 10 things. Actually, yeah, making sure that, I have 10 things. You gotta be careful about that, okay? And so this is the lesson, okay? When you have different values in something in Grasshopper, so like if I have this move thing and I give it 10 numbers, it's going to do a thing like 10 times. And that will give me 10 copies of this thing. So if I make a list of numbers, that's going to give me that number of things, okay? And just to prove that point. So there we go. And this is cool. Like I can change the spacing of it. I can change the width, I can change where it starts, which is less cool. But that is giving you, and to the point that John Nada, who was my mentor at MIT, which I'll talk about later today, said, why have 10 when you can have 100? Easy peasy, right? So that's pretty neat. Remember, this is kind of tricky, but so we have the line command, right? Remember the length of the line, right? It was 50. So this is, one thing. If we apply the same, so this is one number, right? And it gets, the number of things we put in as inputs matters, right? If we have a lot of things and we apply one number, then it just all applies it the same. If we have a list of numbers, it's gonna make copies of that thing, right? Depending on the like amount of things that we have. Also the order matters, right? We made the line first and then we made copies of it, right? So it's different, than and so you have to take that into account. The other thing is with the series component. So I've got this number here and I'm moving it this amount of times. What if I took the series component and I plugged it in? So I made 100 of these things and I moved it like 100 times. So what's happening? Well, the line length is changing each time, right? It's going 0, 9, da, 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 da. So each line is a different length. And then they're getting moved. Each line is getting moved by the number on the list. So the first line moves 0, the second line moves 9. So it's getting taller and it's getting longer as you go. You get like a thing, I'll show you something interesting. So you can take, remember that the like interference pattern I showed you? So like you can take a really simple thing is, right? You make a copy of this thing. Actually, make a copy of more than that. I'm gonna make a copy of all of this. And starts with the line, but I'm gonna change this series, right? And instead of it being like a 9, I'm gonna change this really quick. I gotta move on. Oh, I'm gonna make it a real number. And I'm gonna make it 8. Maybe I just make it 8. Oops, there we go. Yeah, 7. Well, yeah. But you can start to get these interferences with things, like if you're really careful with it. Yeah, I think it was 8.5. I didn't have this like planned out super well. Maybe 8.75. Yeah. In any case, you can get these interferences, right? And so you can kind of play with this, like just like I did, right? He's like, well, what would happen if I did this? What would happen if I did that? You know? And again, I'm just taking a copy of it and modifying it like slightly, to see that. But you can see like how you can quickly kind of stack these things together. How do you get the components and say F on what that? Yes. So those are the unit X's, the unit components, Logan, and Timothy's right. Okay. Anyway, just want to show that really quick. Thank you guys. Thanks for your help. That's awesome. I love that. Okay, so let me prove or demonstrate like another point, okay, with this, and then we'll kind of move on. So we've got, you can take a point, you can take a line, okay, and then you can move it. What happens? Let's go ahead and try the curve. Right now, this doesn't, you can't, moving it, we can't control the length because I drew it, right? But what I can do is I can control the this other piece of it. There we go. Now we're getting into some pop art territory. Oh, hey, and if the background bothers you too, you can just do grid off. Oops, just do take grid off. Yeah, there you go. Now it's cleaner. So again, just to demonstrate the point again, I can make anything. I can make any object I want, and I can copy it, with these commands. Now, it's not a copy command, like it's move. It's just like I'm moving a thing and I'm moving it 10 times or 100 times, but that is causing it to make copies. Right? And this is my line, or I can just delete that. So that you can get like a lot of fun stuff with that, right? So just to make that point, okay. Let's go back to the line though, because I like my little line, my line buddy. And I'm gonna go ahead and turn. Okay, so here's one more thing. Okay, so we've seen that. So that's a series. Okay, I'm gonna go ahead and unplug that for now. Disconnect. So now we're back to boring regular lines. Okay, they're not doing it. It's not doing stuff. There's a series component. There's also a component called a range component. And range is a little bit different than a series. Okay, so bear with me here. Remember, a series like counts, certainly. Yes, you can do a negative number too. You can have a count backwards. You can have it start at a negative number and count forwards. You can do math. You can do whatever you want. Okay, range component takes a starting number and an ending number and it divides it up into a number of equal spaces, which is super useful for architecture because sometimes I don't want to math that hard. Like I need a thing and it's 100 units long and I want to divide it into thirds. I want to divide it 25 times, right? This I got to kind of plan ahead a little bit. Like I got to think about it. It's just different. Okay. So I'm going to plug range in. So it's 0 right now. The way that it starts is it goes from 0 to 1 and it says 10 steps. What you have to know about that though is that let's see, let's just do this. So we're going to do this 10, the count is 10. The way that things count in the computer is from 0. Because computers not operate on ones and zeros, and the people that made them are math nerds, and they think that 0. So you have to be really careful about that. So the series component says like make a series. So start at 0 and step by 1, and it's a 10 count, and so you get 10 things. You go 0 to 9 is 10. If you mouse over this, it says 10 locally defined values. Okay. If you have a range and you say go from 0 to 1. And the 10 steps, that's 11 things. Okay, so you got to watch out for that in the range thing, and I'll show you why in a second. Okay, there's lots of reasons why. Okay, how do you get this to work? Remember, you have a range, so what you want is to construct domain, and the domain is just a starting number and an ending number. Okay, so plug it in. And you need 2 number sliders. So I'm gonna drop a couple hundos in here, a couple hundo sliders. and break off another hundo. And so now I am going to start from 0 to 100. Okay. And then the number, I'm going to go ahead and drop one of these sliders. And in order to make my head hurt less, I'm going to do some math. And I don't usually do this in these things, but this is the exception. Because if I think this is 100, I kind of think I have 100 things. I don't want to think like a computer. I want to think like a Nick, which is like a handsomer computer, basically. Thank you, Ben. So I'm going to right click this and I'm going to say X minus, sorry, not the integer. I'm going to go to the expression and I'm going to say X minus 1. Because then that way, when I put in 100, I don't get 101, I get a round hundo. Okay. Okay. Now I got these numbers. Let me make sure I got this right. Value. Yeah. Okay. And so, so you can see, and these are like weirdly fractional, but more or less, I've divided it up. Let me do like, maybe I'll do 25 or something like that. Yeah, anyway, okay, so let's say divide it 25 times. Now I have these numbers. I can plug that number in instead of my series, and then bam. And actually, I'm going to go back to making my lines nice and tall. And say, Nick, that looks exactly the same. You're a fraud, and I hate you. Well, no, like it's actually a little bit different because now, remember, I can say where it starts and where it ends. And I can tell, I can see how much I want to divide it. And I can also say, when I started to, which is, again, less useful, but that's pretty neat. Okay. And I can do the same thing with my fun, with my fun curve buddy that I've got here. Hello, same thing, right? I can play with it in a different way. Okay. So series, range. Okay. I'll show you something else. Hang on. We're going to bust out a graph mapper. I like math, and I cannot lie, but I do think that it's sometimes it gets in the way of like what I want to do, like especially when I'm in a hurry or I'm trying to make something. And so one of the things I like quite a bit is this tool called the graph mapper. And a graph mapper, let's go ahead and make another copy of this thing here. No data, it's broken. Graph mapper works. I'm going to go ahead and copy this whole thing too. Graph mapper works thusly. So I plug in a range component for it. And what it ends up giving me, and right now nothing is happening. You right click on it and you go to graph types. And then you go and you have horrible flashbacks to middle school geometry because it's about different types of graphing stuff. I don't know what did you guys have? TI-84s, I don't know what, TI-92s, whatever those like graphing calculators. And you could just make a graph. You don't have to like actually put in the polynomial or the formula or like whatever. You can just have a graph. And the one that I like is a sine graph, like a sine wave, right? And you can put that in. So you can go to graph types again, go sine, okay? And you can take these handles and you can draw like a graph, okay? And so basically what this is doing is that it takes whatever you put in as an input and it basically intersects it with this graph. So it's like take this range of values that you have, right? And intersect it with this graph and then give me the end result, right? And I'll show you why that's interesting in just a moment here. Let me just make sure that I've got this right here. Okay, so 100 things. It works a little bit differently because it takes and I actually when I do graph mapper, yeah, okay, so basically, and a graph mapper works, the default domain for it only goes from when you're doing a sine, right? Remember, sines go from 0 to 1 to 0 to -1 again. Okay, so you get like some pretty small numbers. Okay. To make this better, I'm going to go ahead and multiply these. So I can take these small numbers and I multiply them by a big number. And then I get something that looks like something. So humor me here for a second. Let's go ahead and bust out our panel again. Because now that looks like something, right? It's going, and you can see the numbers go up and then they go down, and that's a sine wave. Okay, and you say, well, Nick, like, why are you bothering me with this? Well, okay, let's take a look at this. I'm gonna hide my curve. I'm not using the curve though. Okay, back to lines again. Back to hiding the curve. Okay, so we got our friendly things here. If you take, instead of the numbers, just a list of numbers that just go up, if I take this list of numbers of things and I plug it in, I actually get a pattern. And I can, and I'll this, and so it may not be as exciting in the move. So let's look at this, and I'll show you this before I go on. You can change the graph type. So there's all kinds of different types. Like I can do like a Bezier, which may be less exciting right now than I think it is. Yeah, it's not doing what I want. Oops. Yeah, we'll do something else. Hang on 1 second. Oh, and that's too large. That's why. Okay. So yeah, sometimes with this method that I just did, you have to watch these numbers. Sometimes you don't need to multiply them. That's I'll have to teach that a little bit differently next time. Yeah, I have to reduce the domain too. This is why parametrics are good, because you can play with them. Okay, and let's see here. Oops. Range. Oops. Yeah. Okay. So you can see like I don't know if you can tell the spacing is getting smaller as it goes, and then it's getting longer. And you can change that spacing with the parabola. Some of these are easier to work with than others. There's even one that's kind of a Perlin, and this is a noise one. And Perlin noise is it's an algorithm that makes just noise, just like garbage. And that's kind of fun to play with too. So you can kind of play with these. And like I don't expect you to know like what these are, but over time you will understand them. So that's called Perlin noise. Okay. And so it's not random, but it has the appearance, it's pseudo-random. It looks natural. Okay. So there's a lot of different graph types in here. And we'll talk about that later, but it is another way of making numbers, and it's also a way of making patterns in numbers by exploiting math. Okay, let's go back to the sine wave. So that's like not maybe as exciting in the move. So let's go ahead and just take our oops, not the geometry, Nick. It's the transform. Got a case of the Thursdays. Let's see here. What did I do? Oh, I need this. I need the X. Nick, you broke it. X. Boom. Okay. Now let's go back there. Remember how we can play with that line thing with the line length? Let's go ahead and plug that in for the line length. Oh, now that's cool. Now you got your money's worth this morning. So let's go back to this. Now it's like and the more of these things that you have, right, the more detailed like this becomes. I only have 100. You can see how the sine wave is like kind of working. Super fun. Oh, look at that. See, we get right to, now you got this kind of cool kind of field. Oh, whoa. Oh, neat. I couldn't draw that. I don't know if you guys can see that as well. I couldn't draw that if I tried. Okay, so then what you can do with it, if let's make sure I've got all this going here, is like I can make more of these things. Like again, let's go John Maida on this. Hey Nick, why have 100 of something when you can have 1,000? And we probably need to plug it in for this too. There we go. That's probably too many. funny, the way that we make lines on the computer, or when we make solids, is actually by drawing a lot of lines. Probably need a little bit more spacing on these things. Let's see here. Anyway, you can kind of play with that. I'm not gonna mess with that too much. Whoa, we have a perfect sine wave. We could probably too many of these things. Maybe 300. I don't know. Yeah, that's better. Now we got some lines. Fun. And maybe these other ones will look cooler too. I don't know. Yeah, there we go. Now I got a Bezier. Yeah. Neat. Okay. We'll talk about why that's broken right now. Okay. So numbers. This is so the first of all, move is you take something and you have a transform. You have some direction. Numbers. You can make a number with a number slider. You can make a list of numbers with series, range, and you can edit that. You can put some spice on that with the tools like the graph mapper. Okay, and we'll get into this more later, but I just want to point out, like, you don't just have to make lists that go up and down. You can have things that are like a lot more complicated or a lot more interesting because of math. Okay, now I'll do a quick segue to talk about. So remember when I did this Bezier thing, and it looked like I didn't know what I was doing again because it like does this and then it like forgets what it's doing. Okay, there's a reason for that, and I'll show you something else at the same time. Let's kill this here. By the way, I'm not giving you this script. Like, I'm not, because it's, if you haven't done it, you haven't following along, it's fine, but I want you to build it. Okay. Let's make some points. So construct point. Construct point. Okay. I want to make a lot of points. I could move the points, but I should, because it's good teaching, but I'll show you something else. Let's just do a series. So this is good practice. So like, remember, these are just coordinates, right? 0, 0, 0 equals a point at 0. So if I want to make a row of points, I can just change the x coordinate a couple times, right? And that's what I'm going to do. I'm just going to plug this in so we can keep moving. So I have a list of 0 to 9, and so now I have 10 points. And so again, that's a repeat of the lesson. If I have this thing and I give it 10 numbers for x, I get 10 points. Okay. Now I can take something like a circle, and the circle wants a plane and it wants a radius, right? Do this here. You don't need to do this, but I'm trying to make my teaching a little bit more clear here. I don't like that grid. It gets in my way. Makes me upset. Okay, so I've got a circle, and I just piped it in because when you put a circle in the canvas, it makes that stupid grid, and I don't want to see that right now. So I just put it into a curve to show you. Okay. So the circle is made at a plane. Well, the plane can be defined, an XY plane, by a point, and we do this a lot. So if I take these 10 points, I get 10 planes and I get 10 circles. Okay. So I'm gonna take those circles and I'm gonna move them. So now I'm gonna teach. I'm gonna move. So I'm gonna move, and I want to move them like up. And I'm going to move them up in the, some on the top view. So I'm going to move them up in the y-axis again. Okay. And then I'm going to do a number slider. I'm going to do a number slider for 10 again. 10. Boom. Okay. So, so this is the lesson. Okay. So I had a thing, and I put 10 numbers in, and I get 10 things out. If I take those 10 things and I give it one number, all of them move. All of them, get moved at by the same rate. Okay. let's take a series. So again, just a dumb series, 0 to 9. If I plug that in, so if I have 10 numbers, I'm going to move these objects 10 different ways, and they will correspond. Like the first object, in this thing that's at point 0, 0 doesn't get moved at all, right? 0. Let's do some panels here so I can teach. Let's make, end of points, okay? Actually, I'll do this. This is what I want. Okay, so the first one goes to 0. Second one gets moved up 1 in the Y. 2, 3, 4, 5, 6, 7, 8. Duh. Fantastic. Okay. So if you have listed at the same number, then they're going to correspond to one another. And then they'll just read across that structure. Okay. Remember, if you just have one thing, you're just applying the same thing to it. Since you're curious people and scholars, you would ask yourself, what would happen if I did 2 things instead of just 1? Let's do it. So plug it in, and I'll do my number slider here. The count is 2. So the way this works is that the first transform gets applied across, and then the second one gets applied, and then it runs out of stuff. And it's like, I don't know, Nick, what do you want me to do? I'm a computer. It's like a house painter or something, and you gave, or I don't know, maybe you had to paint by numbers and you ran out of paint, or like all you had is like one color, and so you have to paint the rest of the house or like the rest of the paint by number with the same color, because that's all you got. So it runs out of new things to do. And so it's just like, okay, I'll take that last one and I'll just fill in the rest. So, okay, and that's what it'll do. Now you're curious, and you would ask yourself, but Nick, what if I gave it more numbers than it wants? Like it wants 10, but like as John Maida would say too, like why not 100? Let's find out. Doesn't cost us anything. Yeah. What happened? Well, it ran out of things, right? But you kept asking for the transform, so it just made more. But it made more from that last value. It doesn't throw away any numbers. Like if you give it a number, it assumes that you like want it to do something. Okay. And so this is why you have to be careful. And this is what will break your programs and make you sad. Is that you have to make sure that the amount of numbers like matches, or you'll end up with extra stuff that you don't want, or you'll end up with something repeated without the value that you want. Okay. So this will come up later, but this is the way that Grasshopper handles data. We call this data. I'm sorry. I don't want to have to say like computery junk, but it's true. Numbers are information, they're data. Okay. And so the data list, the data structure like matters. We'll get to this like quite a bit more. So 10 things. But then if I apply 100 things, it's going to make 10, match them, but then the rest of them, it's not going to throw away the next 90. It's going to make 90 things. Okay. And so that's why it's really handy to have these like dependencies in these systems, right? So like, I think you kind of saw it before, like when I plugged in the same slider for these 2 things. That's also why I did this with the range, because I would have had an extra thing. Remember, it's 299, right? Instead of instead of being 301, I wanted it to be 300. These things need to be the same number, or I will end up with an extra like widget. Okay, and so you have to be very careful about that. It's okay if you don't quite grasp that now, but I just want to point out this is the logic of the thing. Okay, so again, you just apply one number to something, to a list of things. It's going to do that to everything. If you apply a list that's the same number, it'll apply whatever those things are to those things. if you apply an unequal number, you will get some form of repetition, either from the original thing or from the transformation or whatever thing you apply to it. Okay, we are not going to be able to get through all this. I'm gonna in the video. I'll make a video. I will with the next 2 transforms. But let me talk a little bit, and then we'll go through. Okay. So again, this covers the big lessons, which is that we did one transform. We talked about how move works, what it wants, what it looks like. And we talked about different ways of getting like numbers in, right? And so it's like, how do we make a lot of moves of something and make a lot of copies of something? Remember, you can move things multiple times. You can make a copy of something and then move it differently to get interference. There's lots of different like strategies for things. The assignment for, let me stop. I need to go to my share here. I didn't get to do what I was going to do. Okay. All right. Sorry. The assignment is going to be this. I'm going to have basically I have these things in this what's going to be a PDF, but it's a PowerPoint right now. But I want you to find some patterns, some kind of repetition in here, and I want you to try to make a sketch of it yourself in Grasshopper. And then I want you to output that as like a nice looking kind of PDF. And then I also want 2 kind of screenshots in Rhino that convince us that it's parametric. You didn't just like draw it in Rhino or something. You know, like what are the variations that are like possible because of the like thing that you've made? Okay. And it gets to a point where you say like, well, how do I write a script? Like, how do I do that? Well, I think a lot of the times it starts by actually drawing it, like try to like break it down and say, okay, like what is actually happening? In this case, you've got like like how would I make this? Well, think about it. It's 2 circles and it's lots of copies like of that circle, right? And so you can say, okay, well, maybe you make 1 circle and you increase the scale of it with a list, multiple times. And then you move that thing somewhere, right? You can break it down into small, like very small steps. Okay. And then try to like build it from there. Now, some of these things are very simple and some of these things are very complex. I don't want you to just email us and be like, Nick, how do I make this thing? I need you to like think about it, break it down, and you can try different ones. And if you're already pretty skilled with this stuff, or you're very curious, which is a thing that I like to support, you are free to like do a lot of fancy stuff or do something really hard. But I'm really just setting the bar. Like, that's a pass. Like you get something, you make it, and it's fine. You do something really complex, maybe that's a high pass. Remember, there's really no like credit for it. This is this guy, Jorg Nies. He's one of the earliest computer artists. He plotted these things. And what is it? It's a shape that he drew. It's a star, and it's just copied, But the rhythm and the white space and the shape and the way it interferes with itself is what's interesting about it. And so that, again, like I've already kind of showed you how to do something like that, already, right? How would you get like a grid? You make a row, and then you move that row up or down in the Y. Easy peasy. So like those kinds of things are not, if you think about those things, you take a step back, they're not true. And I'll show you some patterns for things in my my next lecture, my next video for you. Okay, so you're not going to be flying blind. Remember, like I said on the first day of this module, a lot of programming is about gluing stuff together to say like, okay, I know how to draw a line. I know how to draw like a couple of lines, right? I know how to make these things, so it's like, well, maybe this is like 10 different series or something that you've like arranged with each other, right? Or like, yeah, and then another series going in the like Y direction. Okay. like to Ben's point, there isn't like a book I can give you or something that just has all these things laid out and broken down. Like, but what you do is you play with them for a while until you get like a sense of intuition for how these things work. Just like when I'm playing with a graph mapper, like I kind of know like what it's doing, but like I more know what I think the effect is going to be if I do something. But I couldn't tell you exactly computationally like some of those things, but I know like what shapes I want. So move is done. We're going to look at scale. This is yeah, scale. Okay, we're going to look at rotation. Okay, and if you're adventurous, which I know you are, we're going to look at combining them together. So like, for example, this would be scaling and moving, right? Pretty cool. It's my man John Maida. He was my my mentor at MIT. And this is another one of those Jorg knees. Rotation and scale and movement. You can quit your job and make $1 million as an artist. This is another one of Riley's. It's the oval is negative space. It's a white oval on top of a black field. The black oval slightly rotates. Like if you really fixate on it, it actually moves. It's very cool. I think so. So again, a field of rotating, boxes. Another one of these. Movement and rotation. Okay. And some more patterns. So like make a thing and like copy it, right? So it's a low bar again, like just like take an example of something that you've like found in this. And I would say, you could look at the things that are in this like document. I don't think you have to go looking for things online. If you have something in particular that you want to do, like I would support you, but I don't want you to make this hard. And I don't want to have to help 80 people design their script this week. Like I'm really not want to do that. So take a step back, but the like big lessons of the day, right? It's just the idea of like how like powerful these things are, how like powerful like transformations are, and how with a few simple things like you can actually get like a lot of effects, and especially if you play with them, right? And then the last point I made too is like post-processing them. So like you could, Rhino will give you this, but it would be not difficult to output these things. And then in Adobe Illustrator, add in a fill for these things, to like change the layer of things like that. So that's where you can start to get into like where you can use color to create contrast or to create differentiation between things. But and I mean, you challenge yourself as much as you want. I mean, if some of these things are kind of trivial, if that's what you're comfortable with, I'm not going to judge you, I mean, other than maybe not giving you a high pass for this, but you get a pass, it works. It's fine. And it's not a grade. You did it. But I encourage you guys with the time you have, to really experiment with some of these things and to get maybe some good questions. So again, on Tuesday, we're going to come back and you're going to pin up your thing, and you will get a chance to talk about it, and get a chance to ask questions and see what other people have done, and just kind of get a sense of like the studio as a whole, like how people are grasping these things. I haven't had a chance to see you guys do much of this yet, so that's also why I'm doing this, kind of making it kind of open-ended. Last week's was very like, well, the one that's due tonight, you still have time to take the quiz if you haven't yet. But that was very straightforward. This one, I'm going to give you guys a little bit of opportunity to see, just to see how you express yourself and the things you're interested in, and just how well Grasshopper is going for you, like how like manageable all this is. Okay, so those kinds of things are really just part of my design. And then yeah, so all that will be up on Canvas pretty soon. I don't have the page all done yet, but that's the gist of it. So you've got, if you have some time between now and maybe this evening or something, when I'm going to get the other phase up, you should be able to do a lot with movement. you know, really quick. So I got kind of spaced. I was thinking his class ended at 12:20. Sorry, at 10:20, and it ends at 12:30. So really quick. I can go ahead and I can show you the other transforms just as a kind of amusement. So let's see. Go ahead, and I'm in top view again. And I'm just gonna make, because these things don't really make sense with a circle. I'm just gonna make a rectangle. And once again,
we aren't seeing your Rhino screen right now.
thank you. My thing died. My tablet. Okay, thank you. Awesome. Okay, I'm in Rhino, and I just made a. I'll start up again. Made a rectangle. And rectangles, I don't like the way they're done in Grasshopper, but I won't talk about that right now. Rectangle, and I'm going to put it into a curve just for you because I don't like the grid. There you go. So that's what a rectangle looks like in Grasshopper by default. Okay, so to get that to rotate, you use a rotate or a rotation component. Takes geometry and an angle and radians, and a rotation plane. And the geometry is our rectangle. Oh man, I hate that thing. I don't like the geometry thing. Okay, there, now I can see it. Okay, so here's the original one, and then here's the transform. Okay, and the angles and radians, and it's half pi. Ooh, I don't want to do that. So what I can do is I'm just going to do a slider, and let's just do 0, 180, 360, because 360. And it won't work because it wants radians. So what I do is I use a radians component. And now I've got, and I can just hide this. And now I've got this. Okay, so that's all. And the plane is XY, so I don't have to worry about that. If I'm in a different view, I need to figure out what that plane is. We'll talk about that later, but we don't need it right now. So you do the same thing. I can do a range of these things, and I can say like the range of this construct domain. And it's construct domain. There's no superscript or anything. It's just this dumb domain thing. And I'm going to go ahead and plug this in. Kabam. Kabam. And how many of these things do I want? I don't know. I could probably make a lot of them. John Maida. I plug it in for the angle. Kabam. I can get a lot of stuff here. Now remember so depending on how many of these things I have. Fun. Whee! So you can play with it's the starting rotation and the ending rotation divided how many times? Rotation's fun. Oh, I broke it. Why? Because you can't have 0 things. It's angry. So maybe if I was a nice person, I would design this slider better. I could save 1. Then I can't break it. Remember, this is just a random. I could make this 100 if I wanted to, but it does not like 1. All right, real quick, scale. So scale, and it takes geometry, and it takes a center of scaling, which I like to refer to as a centroid, and a scaling factor. And the scale factor of 1 is the scale that it is. You can think of it as 100%. Scale factor of 0.5 is 50%. Scale factor of 2, 200%, twice as big. Neat. I plug this in. And remember, I've got 14 objects, 15 objects, right? And so, and I've got this scale thing, and I can, let's just do a number slider. I will be done on time. I hope so. So this is just, scale. Now the centroid C is 0, 0, 0 because that's the default. If you want to find the center of something, you can use the area component. And so what you can do is just take this original curve And that C is the center. So that's the way to get something to find the center, no matter where it is. Okay, that's the area component. We'll talk about this. If I had a quiz, I'd ask you about that because that's killer. Most of the time you want to rotate it about the center. If you don't, you can get some really cool like spirograph kind of things. We're not going to do that right now, but we'll do it later. So anyway, that's what it is. So this is, we've rotated everything by the same like scale factor, right? But what would happen if we took something like one of these things? Actually, I gotta be really careful about this one. Let's do a range and let's put in the same number of things and let's put it in here. And so now I can get, and I broke it. Why? Because you can't scale by 0 either. That is a no-no. So let's make sure that this doesn't go to 0 either. Angry, angry code. There we go. Whoa, we have a little yin yang thing there. That's cool. And it still doesn't like us, but it I wonder why I did that. Oh, because the domain is 0 to 1. This is, remember the scale of this one. That's what I did. Construct domain. Oh, domain. You gotta type it in. And let's just do 10 for these. I know you guys gotta go, so. Ooh. So like I can change that. So I can say like I want to scale it from like, and maybe I'll do this as a real number. I can scale it from like something to like 300%. And the more I, so I can so it's rotating it and it's like scaling it. And it's happy. It's like 42 things. Ooh, crazy. Look at that. So if it's just scaled, that's what you get. I got chat. Do I start talking to myself when I create something? Yeah, I talk to myself all the time. I will say this too. Remember how I had, I want you to work in partners? I still want you to work in partners for that reason. Okay. And that if you are talking about what you're doing, it's a way, the rubber ducky method. That's exactly right, Ben. That's right. I've also heard it referred to as the teddy bear method. Like if you have to explain it to some person or something, then you're like externalizing your thoughts. That's what you need to code. You're like, I want to make 10 of these things. This one's like broken. It needs 11 things. Why is it red? Well, it's because it can't be 0, And that's a really good way to learn. It's a really good way to debug your code. We'll talk a little bit about debugging, I think, on Tuesday as well. But anyway, I hope this is like interesting. And my code is messy and it's crap. We'll talk about cleaning this up later too. But for now, just like, just play with it. Just kind of move it around. I do not. Why writing? Yeah, that's right. That's it. Why writing is a form of thinking. Yes. Quickly, I do not want to see your code in your submissions. Unless I ask for it. Okay. To me, the code isn't really that important. I think a lot of people put it with their projects on when I see stuff online and stuff like that. It doesn't mean anything in that format. Like, if you can't run it, there's no reason to like look at it. It's really about the thought process and it's about the artifact at that point. I think people try to like be cool by showing you how many like Rhino, like, how many Grasshopper components they have, That stuff doesn't really impress me at all. Like it's unusable and it doesn't say like anything. If I was looking at it in the computer, that's another thing because I can like zoom around it, and I can play with it, I can read it. But as like a graphic element that you should just put up to say I did Grasshopper, you will. That is not something that makes me very happy on a review. So hey, just something to think about. I may have you post some stuff later, but for now, I just want to see the artifacts for Tuesday. I just want to see what you made and maybe a couple of variations of it or some things you tried or whatever. Okay. Anyway, sorry to take up too much of your time. So I'm going to make this video available, and I've given you kind of the basics on these things, but I'm going to come back and like step through them so you have some of that. If you're really impatient with me, which you could be, there's a video that I made of about 10 years ago that is pretty similar to this topic, but the Rhino interface is different and the Grasshopper is a little bit different, and I cover it like differently. But if you want to like really dig into this thing, just search on my channel. I think there's a video that's called like distribution and repetition or something like that. But you're not going to get the like Andy Warhol and all that and my sterling like beard or anything like that. Okay. All right. You guys be well, be safe. I will see you on Tuesday.
I was just wondering how you get the grid disabled in the preview, because it's annoying me, basically.
The like grid behind the object, like this dumb thing.
Yeah.
That green thing. I piped the geometry into just a curved container to remove that.
It's still there, even though I did that, though.
When you rotate it, you need to put it into another one, because rotate likes to put a grid there too.
Okay.
Yeah, it's something you just gotta get used to. Nobody does this except me, but I think it's cleaner. Yeah, just to show what he's talking about. I don't know if it showed up. Yeah, I don't know. Yeah, sometimes like the grid shows up if you don't do that. It didn't show up this time. Anyway, yeah, that's all it is. Okay, so yeah. But feel free, if you guys do have questions about, I'm happy to answer that kind of stuff. But right now I want to let you guys flounder a little bit for Tuesday. So like on Tuesday we can talk about things that are like, okay, I don't understand how to make this work, or mine is close but not quite close. But I just don't want to like individually tell you how to do each of your things. Okay. Okay. So try some stuff, have some fun. I'll give you more parameters about it, but basically anything out of that PowerPoint is fair game. If you want to do something, there's a lot of cool stuff like mandalas and like some Muslim, kind of patterns. They just has this beautiful sort of history of like tapestries and like tile work and wallpaper. Repetition is everywhere. Think about MC Escher. All right. So have fun. Have a good weekend. Thank you, folks. Appreciate it. Laters. Bye, Ben. Bye, Ellie. Do.